Hello everyone, welcome to another episode of Deep Dive Knowledge Talk. Hello, I would love to learn more about your study on Python packages for GIS applications. Could you please provide me with an overview of how Python is used in geospatial analysis?
Certainly. Python is widely used in geospatial analysis because it provides a user-friendly and powerful study for working with geographic data. It offers a wide range of libraries that enable analysts and data scientists to access, manipulate, and analyze geospatial data effectively. Python's role in geospatial analysis can be summarized in the following key points. 1. Data access and manipulation. Python provides libraries like GDAL and Fiona that allow users to read and write various geospatial file formats, such as shapefiles and geodatabases. These libraries make it easy to extract and process data from different sources, enabling analysts to work with diverse datasets. Number 2, spatial data analysis. Python has libraries like GeoPandas and Shapely that provide powerful tools for performing spatial operations, such as spatial joins, buffer analysis, and geometric calculations. These libraries make it possible to analyze spatial relationships and derive meaningful insights from geospatial data. 3. Visualization. Python offers libraries like Matplotlib, Plotly, and Folium that facilitate the creation of interactive and visually appealing maps, charts, and graphs. These visualization tools help analysts in presenting their findings and communicating geospatial information effectively. 4. Machine learning and spatial statistics. Python has libraries like scikit-learn and PySal that enable the application of machine learning algorithms and spatial statistical techniques to geospatial data. These libraries allow analysts to build predictive models, perform clustering and classification, and conduct spatial analysis. Number 5. Integration with GIS software. Python can seamlessly integrate with popular GIS software like ArcGIS, QGIS, and GrassGIS. This integration enables users to extend the functionality of these tools, automate repetitive tasks, and customize workflows according to their specific needs. Overall, Python's versatility, extensive library ecosystem, and ease of use make it a powerful tool for geospatial analysis. It empowers analysts and data scientists to unlock the full potential of geographic data and make informed decisions in various fields, from urban planning to environmental science and disaster management.
Thank you for the comprehensive overview. It's impressive how Python offers a wide range of capabilities for geospatial analysis. Could you please elaborate on the specialized geospatial analysis libraries available in Python? What are some examples of these libraries and how do they enhance geospatial analysis?
Some examples of specialized geospatial analysis libraries available in Python are GeoPandas, Shapely, and PyProj. GeoPandas is an open-source library that extends the capabilities of Pandas, a popular data manipulation library in Python, to handle geospatial data. It provides a geodata frame object, which is similar to a regular data frame, but with additional geospatial functionality. With GeoPandas, analysts can easily manipulate, analyze, and visualize geospatial data, such as points, lines, and polygons, using familiar Pandas operations. Shapely is another powerful library for geospatial analysis in Python. It allows users to perform operations on geometric objects, such as points, lines, and polygons, like finding intersections, calculating distances, and buffering. Shapely provides a straightforward and intuitive interface for manipulating and analyzing geometric data, making it a valuable tool for geospatial analysis. PyProj is a library that provides geodetic transformations and coordinate system conversions. It allows users to convert coordinates between different coordinate reference systems, CRS, and perform calculations involving distances, areas, and azimuths. PyProj is particularly useful when working with data from different sources that use different coordinate systems, as it simplifies the process of ensuring consistency and accuracy in geospatial analysis. These specialized geospatial analysis libraries enhance geospatial analysis by providing easy-to-use and efficient tools for handling, analyzing, and visualizing geospatial data. They simplify complex operations on geometric objects, enable coordinate transformations, and facilitate spatial relationships analysis. With these libraries, analysts can focus on the analysis itself rather than spending time on low-level data manipulation and transformation tasks. Overall, these libraries contribute to more efficient and accurate geospatial analysis.
Thank you for explaining the specialized geospatial analysis libraries in Python. It's fascinating how GeoPandas extends the functionality of pandas, making it easier to work with geospatial data. Shapely seems to offer a straightforward way to perform operations on geometric objects, and PyProj simplifies coordinate system conversions. In your study, you also mentioned that Python has web mapping capabilities. Could you elaborate on how Python enables web mapping and what libraries or tools are commonly used for web mapping in Python?
Python enables web mapping by providing libraries and tools that allow developers to create interactive web maps and applications. These tools can integrate with web mapping services like Leaflet and OpenLayers, making it easier to visualize and share geospatial data online. One commonly used library for web mapping in Python is Folium. Folium allows users to create interactive maps that can be displayed in a web browser. It provides a simple and intuitive interface for adding markers, polygons, and other geospatial features to the map. Folium also supports the integration of various tile sets, including those from popular providers like OpenStreetMap and Mapbox. Another library for web mapping in Python is Bokeh. Bokeh is a powerful visualization library that can be used to create interactive and responsive web maps. It supports a wide range of mapping capabilities, including the ability to add layers, markers, and tooltips to the map. Bokeh also provides tools for panning, zooming, and selecting data on the map, allowing users to interact with the map in a meaningful way. Both Folium and Bokeh can be used to create web maps that are not only visually appealing, but also highly interactive. These libraries make it easy to incorporate geospatial data into web applications and provide users with the ability to explore and analyze the data in a dynamic and engaging manner. In addition to Folium and Bokeh, there are other Python libraries that can be used for web mapping, such as GeoDjango, GeoPandas, and PySal. These libraries provide additional functionality and flexibility for working with geospatial data in a web mapping context.
Thank you for the detailed explanation. It's fascinating how Python offers libraries like Folium and Bokeh that enable the creation of interactive and visually appealing web maps. These tools seem to provide a great way to integrate geospatial data into web applications and engage users in exploring and analyzing the data. In your study, you mentioned that Python also supports machine learning and AI integration in geospatial analysis. Could you please elaborate on how Python enables this integration, and what are some examples of libraries or tools used for machine learning and AI in geospatial analysis?
Python provides extensive support for integrating machine learning and AI techniques into geospatial analysis. This allows analysts to extract valuable insights and patterns from geospatial data, enhance predictive modeling, and automate decision-making processes. Here are some examples of libraries and tools used for this purpose. 1. Scikit-learn. Scikit-learn is a popular machine learning library in Python that provides a wide range of algorithms for classification, regression, clustering, and dimensionality reduction. It can be used for tasks such as land cover classification, species distribution modeling, and predicting urban growth. 2. TensorFlow and Keras. TensorFlow is a powerful open-source library for numerical computation and large-scale machine learning. It allows users to build and train neural networks for tasks like image classification, object detection, and satellite image analysis. Keras, a high-level neural networks API, can be integrated with TensorFlow to simplify the model development process. 3. PyTorch. PyTorch is another popular deep learning framework that enables researchers and practitioners to build custom neural networks. It is widely used for tasks like image segmentation, point cloud analysis, and satellite image classification. 4. XGBoost. XGBoost is a gradient boosting library that provides efficient implementations of boosting algorithms. It is commonly used for tasks like spatial interpolation, predictive modeling, and anomaly detection. These libraries, among others, provide a wide range of tools and algorithms to process and analyze geospatial data, enabling the integration of machine learning and AI techniques into geospatial analysis workflows. This integration allows analysts to leverage the power of these techniques to gain deeper insights, make accurate predictions, and automate complex tasks in the field of geospatial analysis.
Thank you for explaining how Python enables the integration of machine learning and AI techniques into geospatial analysis. It's impressive how libraries like scikit-learn, TensorFlow, Keras, PyTorch, and XGBoost provide a wide range of tools and algorithms for tasks such as classification, regression, clustering, and more. These libraries seem to offer valuable capabilities for extracting insights and automating complex tasks in geospatial analysis. In your study, you also mentioned that Python supports geospatial data science. Could you please elaborate on what geospatial data science entails and how Python facilitates it? Are there any specific libraries or tools that are commonly used in geospatial data science with Python?